Welcome to The Explainer. I'm so glad you're joining us today because we've got a fascinating and honestly kind of alarming situation to unpack in the world of science right now. Artificial intelligence is driving an absolute revolution in scientific discovery. We're talking about AI generating hypotheses, writing complex code, and even proving high-level mathematical theorems at a pace we've literally never seen before. But this incredible acceleration, it's created a massive systemic crisis. It all comes down to how we actually verify that this new AI-assisted science is correct. Human peer review is quite literally breaking under the weight of it all. So to fix this, Google Research has proposed something groundbreaking, an AI agent called the Paper Assistant Tool, or PAT.
Okay, let's dive into this because these numbers are absolutely staggering. Think about the baseline for AI conference submissions back in 2020. It was around 17,000 papers. By 2023, it crept up to nearly 24,000. But if you consider the projection for 2026, we are looking at an estimated 73,883 submissions. That is an unbelievable 62.9% year-over-year jump. Human reviewers simply do not have the time, or the cognitive bandwidth, really, to read, rigorously evaluate, and fact-check over 70,000 highly technical papers. The whole system is officially bottlenecked.
So here's our roadmap for today's explainer. 1. The validation bottleneck. 2. How PAT actually works. 3. Real-world testing results. 4. 4 roles of AI review. And finally, 5. The future of science.
All right, Section 1, the validation bottleneck. AI is generating science faster than humans can verify. To truly grasp the severity of this bottleneck, consider that up to 40% of specific biomedical abstracts already show evidence of AI generation. 40%. And let's be real, that number is likely much higher today. The scientific method isn't just about coming up with cool ideas. It demands rigorous validation. In fields like math and theoretical computer science, a proper peer review requires days of exhausting line-by-line verification of dense proofs by a human expert. It's intense cognitive labor, and with AI just flooding the zone with new papers, that traditional artisanal model of human peer review, it's entirely unequipped to handle the load.
Moving on to Section 2, how PAT actually works. Let's peel back the curtain on Google's Paper Assistant tool.
Now you might be wondering, why can't we just take a dense 50-page math paper and drop it into ChatGPT or a standard language model? Well, a single LLM call is tightly bound by its context limits. To verify complex math, a model has to generate a massive amount of internal thinking tokens, which quickly exhausts that single call. You might think, okay, why not just run the model 10 times independently? But Pas-it-gay case scaling has huge problems. Independent models hallucinate, meaning they just make up fake errors, and they waste their compute power analyzing the exact same easy introductory paragraphs while totally ignoring the deeply complex proofs. It basically forces human reviewers to sift through dozens of fake critiques just to find one real one.
To solve this, Google built a brilliant workaround. PAT is an agentic framework. Essentially, it's a team of AI agents working together in 4 distinct steps. Step 1 is document segmentation, breaking the paper down into logical themes like methodology or experiments. Step 2 is my absolute favorite, adaptive budgeting. PAT acts like a smart project manager, assigning heavy, high-thinking compute power to the dense theory sections and light thinking to the intro. Step 3 is deep review, where specialized agents dive deep into their assigned sections in parallel. And finally, Step 4 is global synthesis, where the system deduplicates critiques and even uses Google Search to ground its findings and eliminate those hallucinations. It is a total masterclass in AI orchestration.
Section 3. Real-world testing results. Let's see how PAT does in the trenches.
Now, what's really interesting about these results is the massive leap in performance when it comes to accuracy. The Spot benchmark tests if an AI can find organic, human-authored errors in math and computer science papers that actually had to be retracted. The old state-of-the-art AI only caught 21.1% of these fatal errors. A standard run of the powerful Gemini 3.1 Pro model caught 55.2%. Good, sure, but it still misses nearly half. But PAT? Using that exact same Gemini model wrapped in its 4-step architecture, it catches an incredible 89.7% of the errors. It didn't just accept complex math at face value. In one case, Pat literally constructed a concrete counterexample to expose a fatal gap in a theorem. No way, right? The real-world reactions back this up too. During pilot testing at major scientific conferences, Vijay Vazirani, a distinguished professor at UC Irvine, called the feedback simply mind-blowing. Pat pointed out a subtle but fatal bug in his algorithm that had evaded his human team for months. Because the AI caught it, they were able to rewrite 7 to 8 pages of technical content and fix the science before it was ever published. And here's another fantastic example from the pilot. Jason Lee, an assistant professor at Carnegie Mellon University, noted that Pat spotted a technical error that was easily fixable, but still took him 2 full hours to write down the mathematical correction. This proves Pat isn't just a glorified spell checker, it's diving deep into the logic and saving top-tier scientists hours of grueling verification work.
The impact goes way beyond just fixing typos. In the ICML pilot program, the results were completely transformative. Over a third of the authors said Pat found substantive gaps in their theory, but most impressively to me, 31% of the scientists actually went back to the lab and ran entirely new experiments based on the AI's automated critique. Pat is literally driving better, more rigorous science by acting as a highly intelligent sparring partner.
Section 4. 4 Roles of AI Review, or the taxonomy of AI-human collaboration. We desperately need this taxonomy, by the way, because AI-generated reviews are already secretly infiltrating major conferences.
And this brilliantly illustrates how we can categorize the progressive shift in AI-human collaboration, much like the different levels of self-driving cars. Role 1 is what we just saw, AI as a tool for authors to prep their work. Role 2 is AI as a tool for reviewers, helping human judges draft their critiques. Role 3 is a massive leap, AI as a supporting reviewer, where the AI generates a completely independent, objective assessment of the paper's math and logic, and a human committee chair uses that to make a final decision. And finally, Role 4, total AI automation. That's where the AI is fully in charge. Which brings us to Section 5, the future of science, total AI automation and the concept of an AI archive. Now, before you dismiss the idea of an AI deciding what is and isn't good science, consider this really uncomfortable truth. Human inconsistency in peer review acceptance decisions is currently at 23%. Think about that. If you route the exact same paper to 2 different human review committees, they disagree almost a quarter of the time. Human reviewers have biases, we get tired, and we miss things. An interactive, automated repository, an ARZIC if you will, could run papers through endless rounds of tireless, objective AI scrutiny, without the human bottleneck. Papers that survive would earn a high confidence rating, creating a whole new streamlined ecosystem for scientific publication.
But all of this brings us to a profound, almost philosophical crossroads. As AI systems evolve to accelerate the generation of science and simultaneously act as the rigorous validators of that science, we have to ask ourselves a really fundamental question. If AI generates the hypothesis, writes the code, runs the experiment, and then another AI system successfully peer reviews and publishes it, who is the scientist? What is the role of human intuition, creativity, and debate in the pursuit of truth? It's a thrilling yet daunting frontier, and it's one that we are stepping into right now. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you next time.